5.2 is going to be about exponential functions. So before we get into exponential functions, we want to make sure we feel comfortable with all the rules of exponents, all right? So 5.2a's are just some product, quotient, and power rules using exponents. So we're going to kind of derive the rules. So we're going to prove these rules with some examples, okay? So it says, let's write the expression x to the fourth in expanded form. So what does the x to the fourth mean? You got it. So x times itself 4 times. Does everybody agree with that? Is that okay? So then the second part says, simplify what x to the fifth times x to the third would be by actually writing it in expanded form first, okay? And then you'll see what happens. So x to the fifth would be what? You got it. There's x to the fifth. And then times, right? X to the third, which would be, so what do we end up with there? We end up having a total of how many x's? 8. So what's a concise way to write that? X to the 8th, all right? So we just derived the rule that we can fill in the box with. It says, what is a quicker way to find the above answer? Whenever we take the same base, so like in this case it was x, raised to 1 power times the same base raised to 1 power, what can we do with 5 and 3 to get 8? We add them. So let's just kind of write that off to the side. So we're going to add exponents, right? So that's kind of the layman terms, right? But over here, how can we write it with notation? Well, notice even though we wrote x 8 times, when it comes together, we only write the base once. So what's the base here? Just a. And then we just show that we add the exponents like that. Okay? So that is the rule. One thing I just want to note, though, that's only if the base is the same, right? So we have x to the second and y to the second. That just stays x to the second, y to the second. It doesn't become x, y to the fourth. So the bases have to be the same. So notice a and a match. So we can actually quickly do these examples. So let's just look at example 1. Into the 6th will become what? Into the 12. And then y to the 4th times y to the 9th times y to what power technically? 1. First. So that will become y to the 14. You got it. All right, so here they're throwing in coefficients, but that's okay. We can just multiply the coefficient. That will be the coefficient in front. You got it. So 4 times 5 is 20, and then x to the 12th, is that what you said? 9th, yeah, sorry. I can't add there. I thought that was 5. It's 2, 9th. Like, I don't think I heard 12 come out. X to the 9th. Perfect. All right. And then here, I know it's kind of interesting, but it's the same idea. X plus 2 is the base, correct? So how can we rewrite this? This is x plus 2 to the 7th. You got it. All right. So this is what I was talking about. It's only if the base is the same. So we have x to the 2nd times y to the 5th times x to the 1st times y to the 6th. So we can only combine the exponents of the x's together and then the y's individually, okay? So it'll be x to what power? And y to what power?
11.
You got it. And then, you know what? I forgot my notes. So somebody, you have your calculator out, right? So what we're going to do here, we're going to write it in the combined exponential form first. But sometimes MyMathLab, if the base is a number, it'll want the actual answer, right? So this is 2 to what power? The 8th. But MyMathLab might want you to do that in part A, but in part B say, what is 2 to the 8th? Thank you. I keep forgetting to bring my CoRec binder. I just keep bringing my stats binder. I'm like, I don't have any of my notes. All right. So then we're going to do the same idea. We're going to derive the formula for what do we do when bases are on top of each other. So let's look at the next example. We have x to the 5th over x to the 3rd, and we want to simplify it, but let's write it all out first. So x to the 5th would be 5x's all over x to the 3rd, correct? But what do you notice happens when we write it that way?
2 of them cancel. 3 of them cancel.
3 of them are going to cancel, right? So, because they're a power of 1, technically. So x over itself is 1, x over itself is 1, x over itself. So this ends up just being what? X to the 2nd. But again, look at our initial exponents, 5 and 2, or 5 and 3. What can we do to 5 and 3 to get 2? Subtraction, absolutely right. So let's write that off to the side, subtract exponents. And again, realize once we did it, we wrote the base only once. So over here for our formula, we're going to write the base only once. And then we're going to show that we subtract exponents. And that's kind of a visual. It's like the ones on the bottom kind of punch out the ones on the top, leaving them with only a few that remain. All right, let's go ahead and do example 1. That will be y to what power? The 5th. This will get one, I kind of do my coefficients first. So 8 divided by 2 will be what? 4. And then y to the 3rd. And then again, their base is m minus n. So that'll stay m minus n, but that will be to what power? 60th. And then we can do each of these individually, focusing on just the a's first. So a to the 3rd and b to the 3rd. Another way we can write that, so that is fine, but another way we can write that we'll learn in a different section, okay? And then this ends up being what?
Just n.
Yeah, not just n, but n to the 0 power, or 1, right? So this is actually n to the 0 power, which we are going to learn in a second. Anything to the 0 power is 1. But we haven't technically learned that yet, so just realize anything over itself is just always 1. All right? Are there any questions on the front page? So when you multiply the bases, just add the exponents, and when you divide bases, subtract the exponents. All right, here's the 0 power I was just talking about. For any base, it does not matter if it's any base other than 0. So it can be a big number, a small number, a positive number, a negative number. To the 0 power, it's always just going to be 1. All right? So be careful, because you want to quickly just go through, right, 1, 1, 1, 1, 1 to the answer. But not everything in examples 1 through 4 are to the 0 power. So the part that's to the 0 power will be 1, but you might be doing other math with it. So n to the 0 power will just be 1. And then all of 5n is to the 0 power, so that is just 1. But here, notice the n is just with the 0, so that's just 5 times 1, or 5. Exactly. And this is kind of the same idea on example 4. Just the 2 has the 0 power, so that's just 7 times 1, or 7. So you just got to be careful about that. All right, so anything to the 0 power is 1. Then the next idea before we get to the very last thing is this whole power to power rule. So again, we're going to write it out the long way. So let's just write it out. What is x squared to the 3rd? Well, that's x squared times itself 3 times, correct? But what did we just learn on the front page? When you multiply the same base, what do you do to the exponents? You add them. So x squared to the 3rd is equivalent to x to the 6th, right? 2 plus 2 plus 2. So we're just trying to prove what the rule is going to be, right? So x squared to the 3rd is x squared times x squared times x squared. What happens when you add 2 3 times, you get 6. So what math operation can you do with 2 and 3 to get 6? Multiply it. So we're going to multiply exponents.
Oh, that's fine. I did say that.
So again, to rewrite it, a will stay our base, but then we're going to just show that we're multiplying our exponents. Okay, and we'll just go from there. So example 1 will be x to what power?
15.
The 15th, because 5 times 3 is 15. Example 2 is 1 again, since the base is a number, that we'll probably write it in exponential form first, but then they might ask for what the actual answer is. So 2 to the 3rd to the 4th is actually 2 to the 12th, but what is that when you do it in your calculator?
4,096.
So they might take both or want one or the other. And then how are we going to write example 3? It'll just be x plus y to the 24th. Yay! All right, last rule, I kind of call it like a distributive rule. What happens if you have a product and you want to cube it? Again, I'm going to do it the long way. xy times itself 3 times looks like that. But then you just do what we did on the front page. How many times did we multiply x? 3 times. So it's going to be x to the 3rd, y to the 3rd. So what I call it is like a distributive property. Only if it's a product. If there's a plus there, like if that was x plus y, that's not the same thing. But since this is a product, You just take the cube to the x and the cube to the y, right? So you distribute, I'll put quotes, distribute the exponent. So he's shared amongst everything in the parentheses. So what is the mathematical form of that? That will just be a to the m times b to the m. And then they're just going to complicate it because they're going to make like all the rules combined, all right? So example 1 and 2 are pretty straightforward. Example 3 and 4, they have a little bit more going on. So on example 1, we're just going to distribute the 7 to the m and the n. So that becomes n to the 7th, n to the 7th. Does that look okay? Example 2, note that you have two things in there, the 2 and the n. So the 4th power is going to go to the 2 to the 4th, and the n. Okay? And what's 2 to the 4th? Is that 16? Okay. So this is really 16n to the 4th. All right, so here we have two things going on, okay? So we have this whole idea of distributive property, but we can't forget when we have a power on the inside already and we're distributing a power, we're multiplying, okay? So when we do this, this is going to become what? X to the 12th and y to the 30th. Perfect. So it's kind of a combination of the multiplication and the distributive. And then this is the same idea. Be careful if your coefficient's negative, put parentheses around it because it's going to make a difference. So this is negative 3 to the 5th, x to the 5th, y to the 20th. Is that all right so far? And since it's an odd power, whether we have those parentheses or not, it wouldn't make a difference. But like if that was to the 4th power, that negative would make a difference. So we want to be careful there. What is negative 3 to the 5th power?
Negative 243.
Thank you.